Welcome to Brain Vision.
In this problem, we have a hinged beam with two linearly varying distributed loads. And we're asked to find expressions for v of x, m of x, and to find the location of the maximum bending moment. All right, we can look at this from a pretty mathematical point of view. We can draw the resultant loads of our two distributed loads here, and we can find the reaction at A just using a sum of forces in the vertical direction and setting them equal to 0. We've got our A minus a W0L over 2 plus W0L over 4 equal to 0. So we get a reaction at A equal to W0L over 4. And we can use that as an initial condition equal to the shear at point A. And then what we'll do is we'll use this expression for W. We'll find an expression for W, and we'll use that to find a function of V according to V equals minus integral W of x dx. And then we'll use that to find an expression for m moment according to m equals integral of v dx. First thing we want to do, find an expression for w of x. Now we can combine these two linearly varying distributed loads into one. So the first we'll write as W0 over L times L minus X. And so that's this left resultant. And we'll subtract from that a W0 over 2L times X. Gives us the result W of x equals to W0 times 1 minus 3x over 2L. Okay, so this we can use to find our V of x and our M of x, and we'll use our initial condition that the shear at A is equal to the reaction at A, W0L over 4. All right, so we get V of x equal to minus integral W of x. And so we'll take out a constant W0, and we'll have 1 minus 3x over 2L dx. And the result of this will be a W0 and quantity 3x squared over 4L minus x. And we have our integration constant C. And we know our C should be according to VA. C equals to V of 0 equals to VA equals W0L over 4. Okay, so we can write our V of x as the expression W0 3x squared over 4L minus x plus L over 4. And we're going to factor out an L over 4. This is going to make it easier to solve this equation and to find a maximum for M. All right, so when we do that, we get a 3 in x over L squared minus a 4 x over L and a 1. Okay. And so this is our V of x. All right. Now we can use that to find our M of x. All right, so we're going to go M of x is integral V of x. All right, so we'll factor out that constant W0 L over 4 and integral 3 x over L squared minus 4 x over L plus 1 dx. And here our result will be a W0 L over 4. And we'll have x cubed over L cubed minus 2x squared over L plus x. And again, we'll have our integration constant. Now we know that M of 0 is equal to 0. The moment at the end of our hinge is equal to 0. Right, so our integration constant here will be equal to 0. So we can write our M of x as the following, where we'll factor out another L. W0 L squared over 4. And we'll have an x over L cubed minus a 2 x over L squared plus an x over L. All right, and that will be our expression for M. All right, so we've got our expressions for V and M. Now we want to find the maximum for M. Right, so the M max are going to occur when its slope is equal to 0, and those will be points where V equals to 0. So if we scroll up a little bit here, and if we look at our V, okay, so we want to set, we can ignore the constant, and we can set our 3 x over L squared minus 4 x over L plus 1 equal to 0. Okay, this is why we factored an L out. We're now able to factor this simply, and we're left with, for our V, we have either, so this will factor into a 3x over L minus 1 and an x over L minus 1 equal to 0. Okay, so we've got two solutions for V equal to 0. We've got x equal to L over 3 and x equal to L. So we just need to examine those two cases to find which gives the maximum for M. And at x equal to L over 3, all right, we get our M equal to our constant, and we'll get 1/27 minus 2/9 plus 1/3. And we'll see that factoring this into x over L simplifies this. And we'll get a W0 L squared over 27. And let's check at x equal to L. Our expression for M will be W0 L squared over 4. And we're going to get a 1 minus 2 plus a 1 equal to 0. Okay, thus we get our maximum when x equals to L over 3. All right, so our M max is going to be equal to W0 L squared over 27, and that will occur at x equals L over 3.